Welcome to Lesson 9 in Saxon Math Course 3. Today we're talking about prime numbers. Our objectives for today: after this lesson you should be able to identify counting numbers as prime or composite, use an area model to demonstrate prime and composite numbers, use factor trees and division by prime numbers to find the prime factorization of counting numbers, and understand and apply tests of divisibility. Some review from Lesson 8. Remember the two things we talked about, perimeter and area. Perimeter is the distance around a shape, found by adding up all the sides. Area is the amount of space inside a flat shape. We only did rectangles. Remember the formula for area is length times width, and your answer will have a label that is squared with the small raised 2 after it. If you double the measurements of a shape, that doubles the perimeter, but it will multiply the area by 4. And then remember we worked on those L-shaped complex shapes. Just add up all the sides for perimeter, pretty simple, but to find the area you will have to split it into two smaller shapes. Let's talk about prime numbers. Prime numbers are counting numbers that are greater than 1 that have exactly two factors, the number itself and 1. So for example, 19 has only two factors. There's only two numbers you can divide 19 by without getting a remainder, and those two numbers are 1 and 19. So that would be a prime number. Composite numbers, on the other hand, are counting numbers greater than 1 that have more than two factors. So for example, 21 has more than two factors. It has 1, 3, 7, and 21 that it can be divided by. So that would be a composite number. Prime factorization, which I know you love so much from last year, that's a way of writing a composite number as the product of prime numbers. And remember that if we want to find the prime factorization of a composite number, we use a factor tree. Here's an example. If we want to find the prime factorization of 120, I would take 120 and I make two branches coming off of it, and I think, what's a multiplication problem I know that equals 120? Sometimes it helps to try to make the two factors as close to the same number as you can. So for this one I will do 12 and 10. It's going to make this a little bit smaller of a factor tree then. 12 I know I can do 4 times 3, and remember we only stop when we get to prime numbers. So 3 is a prime number, I'm going to stop there. And then 4 would be 2 times 2, and those are prime numbers, so I'll stop there. Then I'll go over to the 10, which would be 5 and 2. Both of those are prime numbers. So then I just list them in order from least to greatest, and I put, usually they do a dot in between them. And we're going to make sure that for now we don't need to use exponents yet. We'll talk about that later on in the year, but for now we just make one long multiplication problem. So I have 3 2's, so the prime factorization, I'll put an equals here, would be 2 times 2 times 2. There's my 3 2's. I have 1 3, and I have a 5. So if I were to multiply all 5 of those numbers together, it would equal 120. Now let's look at some divisibility rules. These are useful when you're trying to think if you can divide a number by something and you don't want to actually try the division. They're only useful though if you can remember them. So if you ever get stuck on these, make sure you look in your lesson, in your book. They have these written down for you. Or you can always come back to this video and look at these couple screens that will have all of them on there, but we're going to go through them kind of fast. So a number is divisible by 2 if the last digit is even. For example, 1026, 6 is an even number, so that would be divisible by 2. A number is divisible by 3 if the sum of the digits is divisible by 3. So example 234, 2 plus 3 plus 4 would be 9. 9 is divisible by 3, so that whole number is divisible by 3. A number is divisible by 4 if the last two digits are divisible by 4. 10,812, our last two digits are 12. 12 can be divided by 4, so that would be divisible by 4. A number is divisible by 5 if the last digit is a 0 or a 5. So 123,465, my last digit is 5, so I can divide that one by 5 also. 6 is an easy one because if your number meets the rules for 2 and 3, then it also works for 6. So 624, last digit is even, so it works for 2. If you add those up, it would be 12. 12 can be divided by 3, so this whole number is divisible by 2, 3, and therefore 6. A number is divisible by 8 if the last three digits are divisible by 8. So the last three digits in here are 24, 0, 2, 4, so 24. So that would make this number divisible by 8. A number is divisible by 9 if the sum of the digits is divisible by 9. It's a lot like the rule for 3. This time we're just seeing if it can be divided by 9. So if you added all these digits up, 27,657, we would have 27. Yep. 5 plus 2 is 7. 7 plus 7 plus 7 is 21. Plus 6 would be 27, which can be divided by 9. So that whole number is divisible by 9. And finally, a number is divisible by 10 only if the last digit is a 0. So there's an example. Last digit is a 0. Notice that 1 and 7 are not on this list. 1 is an easy one because every whole number is divisible by 1, so that one doesn't need a rule. And 7 doesn't really have an easy rule, so if you want to find out if a number is divisible by 7, you actually have to do the long division to figure it out. Sorry, no shortcuts on that one. That's all for your lesson today. Take a look at your practice problems and post any questions you have to the discussion section so we can talk about them in class. And we'll see you in lesson 10.